Hi, this is Mr. Rain going over the pre-calc chapter 4B test, April 6, 2018. This is version A. So version A, max amount of points was 100. You guys got to look at the 3 tests, and this was the hardest one. Number 1, compared to the graph of y equals cosine x, the horizontal phase shift of y equals cosine 1/4 x plus pi over 2 is. So a horizontal shift, you're looking for the value of c. In this problem, you'll recognize that you have, some textbooks have this as b, but I've taught you that the b you must factor out. So you're going to factor out a 1/4. So cosine of 1/4 times x times something. Now I put a box here. Let's just say you don't know what to do here, especially if it's a fraction. So factoring is opposite of distributing. So if I multiply 1/4 times x, I get 1/4 x. 1/4 times the box is going to give you pi over 2. So make an equation. 1/4 times the box equals pi over 2. Well, you would have to multiply 4 on both sides to solve for the box, and the box is equal to 2 pi. So 1/4 times x is 1/4 x. 1/4 times 2 pi is pi over 2. Here it's a plus sign, so you're going to have to change it to a minus. So cosine 1/4 x minus negative 2 pi. You might be asking, why did I change the plus to 2 minuses there? It's because when you have your letters, cosine of b parentheses x minus c. So parentheses the same. What's different is that c is a negative 2 pi. And so a negative 2 pi, a negative c value makes you go to the left. So your answer is C. Remember my phrase, add to x, go west or left. Here is your adding to x. You're going to go left in that position. Let's look at some student work. I wanted to show you the student work or what the student was doing here. They show you multiplying by 4 on both of these. It has to be the same number, and they did that. So 4 times 1/4 gives you a 1. You want that to be a 1, so you're going to pull out a fourth there. Then you multiply 4 times pi over 2 gives you 2 pi. And that works, because that gives you cosine 1/4 x plus 2 pi. Question number 2 says, find the value of tangent, the inverse of tangent of radical 3. So the first thing I did is I set it next equal to a variable, which is alpha. It tells me to take the inverse, so I switch them. I get tangent of alpha equals pi over 3. It is a positive. Tangent is positive in quadrants 1 and 3. I'm looking for a radical 3, so that's y over x, or a y value that's radical 3 and a value, x value that's 1. So 1, 2, 3. So there you are up here at pi over 3. And then down here, that'll give you 2, 3, 4, 5, 6, 7, 8 pi over 6, which is 4 pi over 3. Now if you notice these two values, pi over 3 and 4 pi over 3, you'll notice that this is not in the inverse of tangent's new range. It has to be between negative pi over 2 and pi over 2. So what was the version? If you look at version C, I put the chart there for them. Versions A and B I did not, so if you look at it, it has to be between negative pi over 2 and pi over 2. So in our problem, they're not in there. So what you can do is, well, if I double these, I get 2 pi over 6 and 8 pi over 6. I want the denominators of 6, because then I can just multiply these by 3 over 3, 3 over 3. That gives me negative 3 pi over 6 and 3 pi over 6. And you recognize that within this range, 8's not. 8's over here on the number line, and negative 2, or positive 2 is like right there. So 2 pi over 6 works. Therefore, the answer is pi over 3. Not sure if student knew it was pi over 3, but not sure if they knew that the inverse range or the restricted domain values. Definitely have that table copied onto your table or onto your formula sheet or memorized. Question number 3, given the function y equals 3 minus 2 cosine 4x minus 5, determine the period and the phase shift. This is actually the same question on version B as well. If you haven't already, you're going to make sure that you write the letters. Before I do that, I'm going to factor out a 4. 4 comes out. Remember, it's to check your answer, it's 4 times x. 4 times something equals 5. So 4 times the box equals 5, and you divide by 4 there, so your box is equal to 5/4. So I have them there, and then you're going to put your letters below them. So your d value, it's a constant the a value is in front to left side of the trig function, b value is on to the right of the trig function outside the parentheses, and c value is inside the parentheses. So my b value of 4, and you have cosine, period is 2 pi over b, so 2 pi over 4, which reduces to pi over 2. That eliminates choices C and D. Now I need to pick between A and B. If you write the letters below, you'll see that parentheses is the same, x is the same, minus sign is the same, C value is different. Therefore, your C value is 5/4. Because C value is a positive, it's going towards the right. So the answer is B. Remember, I don't have it written on here. Add to x, go west or left. And you can cross A off because it's not a adding there, that's a minus sign. Just in showing how I found the period. I liked how they factored, and even they put this parentheses there to show that this is a positive 5/4 to help them recognize the C value is positive 5/4 right. Nice. Question number 4 for the A version, what is the value of tangent, parentheses, arc, cosine, radical 2 over 2? Now this type of problem was the free response question for version C, so I'm just making A version more difficult problems. First thing you're going to do is you're going to set all of that equal to a variable, and I chose x. So you need to find tangent of x. Now in this problem, you're going to say x is equal to the arc cosine radical 2. And then when you take, the arc is another word for the inverse, so if I switch the radical 2 over 2 and its position with the x's, I get radical 2 over 2 equals cosine of x. Cosine is the adjacent over the hypotenuse, and since cosine here is positive, I'll just work in quadrant 1. The adjacent side is radical 2, and you can either use the Pythagorean theorem or recognize this is a 45, 45, 90. So therefore, your legs are radical 2 and radical 2. And that's all I need because we're looking for tangent, which is opposite of the adjacent, and that would give us a positive 1. So again, you could have done the Pythagorean theorem to solve for the other side to be a radical 2. Here's a student found the inverse of cosine. Cosine is radical 2 over 2, correct? Nice little triangle, 2, 4, 2b is radical 2. And then I think because they only have this, we don't see any of the work, maybe they thought it was just this. But remember, you're looking for tangent here. So if you had put this radical 2 over here, then that would be the opposite of the adjacent. Radical 2 over radical 2 is 1. Here's my solution for the Ken-Ken. 6 points for 5 by 5, and 1 point if it was incorrect. Versions B and C had a 4 by 4. This side was out of 40 points. Turn to the back side. Use the right triangle to write the expression as an algebraic expression. This was out of 30 points. Normally I graded this point out of 4 on my rubric. So if I do a proportions cross multiply, I get x equals 7.5. So if I normally award you, say, a 4 out of 4, you would get 30. If you got 3, that's 3 times 7.5 give you 22.5. So the problem, set it equal to theta. I'm trying to find cosecant. Theta is equal to the inverse of tangent of x over radical 3. I know the temptation might be for you to rationalize, but again, you're not simplifying, you're just trying to find an angle. So the first thing I'm going to do is go ahead and take the inverse, which means my arrow is switching them. Tangent is positive here, so I can work in quadrant 1, and then I have opposite over the adjacent. So the opposite side is x, the adjacent side is radical 3. To find the third side, the hypotenuse, I can use Pythagorean theorem. My two shorter legs are, I call A and B, do not matter how you label them. Most important is C value, which is across the right angle. We're trying to solve for C there, so I put in there radical 3 times radical 3. It's just radical 9, which is 3. X squared is x squared. And to get rid of the power of 2, I'm going to take the square root. C is equal to the square root of x squared plus 3. It's a plus or minus, but remember, we're only picking the hypotenuse has to be positive because it's a distance. From there, since my C value is square root of x squared plus 3, don't be tempted to simplify that there. We're looking for cosecant, which is the hypotenuse over the adjacent, so that would be square root of radical 2 plus 3 all over x. 1 point for trying. Let's just say you took the inverse, and you have this right here, tan theta equals x over radical 3. You got 2 points, multiplied by 7.5 gives you 15. If you got square root of x squared plus 3, you got 22.5, or maybe, I don't know, minus sign could be incorrect. So look at some work. Here's an example of a full credit problem. Notice how here they switch the a's and b's to mine, which is totally fine. Here, order does not matter. 3 plus x squared, square root of 3 plus x squared is the same thing as square root of x squared plus 3. Here's a problem where, oh, I can stay there. They got the inverse, so that's essentially my 2 out of 4 or 15 points. Here they tried to rationalize, and remember you only rationalize if you're trying to simplify, or you might want to be solving, but in this case we're not solving or simplifying an equation, we're just trying to find the angle of cosecant, so I would not do that. If you did, you still would get, let's see, 3 x radical 3 all over 3, correct. This would become, right here, this would be 3x squared. That would become 9. And then you could just factor out the 3, and you'd still be the same. Question number 9, graph the following functions over one period. Be sure to include a table of values and label your axes clearly. I labeled this, or this is out of 30 points, and I looking for 5 criterion, and I made a proportions, therefore each of the values are 6. Now, do not think this means if you found the period you got 30 points. Just think of the black and red as separate. So the 5 criterion, you get 1 point for the period, 1 point for x values and x intercepts, 1 point for the table, 1 point for graph accuracy, like the asymptotes in the correct regions, and then 1 point for the graph shape, meaning, let's say I give you secant and you did not graph tangent. So the first thing I'm going to do is I'm going to find the period. In order to do that, I'm going to have to factor out a 3. When I factor out the 3, I get 3 times quantity x plus pi over 12. How do I get pi over 12? Let's just say you don't know what that is. 3 times a box equals pi over 4. Divided by 3 on both sides, you'll get the box is equal to pi over 12. Because it's a plus sign, change it to minus minus. And remember, for me, what I've shown you guys in class is that you're going to graph cosine. You're going to graph its reciprocal, and then we'll erase it and then graph above it. And this is the same principle with the table, so a lot of you guys may have made some mistakes. Put some A, B's, and C, D's below it. A value is -1, B value is 3, C value is a negative pi over 12, and your D value, the constant, is -2. A value -1, my B value is 3, so the period for cosine is 2 pi over B, so which is substituting the B value, so you get 2 pi over 3. It means it has a length of 2 pi over 3. C value is negative pi over 12, which means it's going to be a phase shift to the left. There's my graph. It's originally started in the origin, and it's pushed off now negative pi over 12. D value is -2, so it's going to be a vertical shift down 2. Although the length of the graph, completion of one graph by one period, is 2 pi over 3, we're going to have a start point and end point. My start and end point, I'm going to put everything to the right of the trig function, and you can choose any of these. I just chose to use the factored form. 3 times x plus pi over 12 here. I'm going to divide it by 3 on each of those, so I get 0 less than or equal to x plus pi over 12, and then 2 pi over 3. Here I'm going to subtract 12, subtract pi over 12, so I get negative pi over 12. That cancels x, and then over here, to subtract pi over 12, I multiply numerator and denominator by 4 to get an equivalent fraction of 8 pi over 12, and you subtract the numerators. 8 minus 1 gives you 7 pi over 12. So there's my start point, end point. If I take -1 plus 7, -1 plus 7, that gives you 6, and 6 divided by 2 is 3. So 3 pi over 12 is my midpoint, and if you reduce that, you get pi over 4. Circled it. From here, -1 plus 3 gives me 2. 2 divided by 2 is 1, so that would be pi over 12. And then over here, 3 plus 7 is 10. 10 divided by 2 is 5. And you'll notice you're just counting every other: -1, 1, 3, 5, and 7. Those become my x values. And basically what I'm going to do is I'm going to work from right to left, or essentially you're using the order of operations. So now that I have my x values here, I use the factor form here. So essentially what I'm going to do with my x value, I'm going to go ahead and add pi over 12. When I do that, I get 0, 2 pi over 12, which is pi over 6, pi over 12 to 3 pi over 12 gives me 4 pi over 12, which is reduced to pi over 3. Pi over 12 plus 5 pi over 12 gives me 6 pi over 12, which reduces to pi over 2, and 1 pi over 12 plus 7 pi over 12 gives me 8 pi over 12, which reduces to 2 pi over 3. The next thing I'm going to do is then multiply my x values by 3. So if you multiply there, you get pi over 2, pi, 3 pi over 2, and 2 pi. There's my golden row for, cosine. With these values now, I'm going to go ahead and multiply those after I get my golden row for cosine, then I'm going to find cosine at 0 using your unit circle. That's just 1, 0, -1, 0, and 1. The next thing I'm going to do, going from right to left, is this is multiplication. So -1 has its relationship with the trig function by multiplying by -1. So I'm going to multiply those numbers by -1. And the last thing I'm going to do is add the d value. And adding the d value is adding -2. So that gives you -3, -2, -1, -2, -3. Now I'm going to graph those points. Negative pi over 12, I have -3. They're in green. Pi over 12, I have -2. Pi over 4 is -1. 5 pi over 12, -2, and then 7 pi over 12, -3. So there's the graph of cosine. And then what I'm going to do is, we've learned that where the graph would have crossed the x-axis is your x-intercepts, the original graph of cosine before the vertical shift, horizontal shift, and all the dilations would have been here at negative pi over 12 and 7 pi over 12. So I'm erasing the green, and then I'm going to graph above it. And there's my graph. Here's a couple of ways you can double check your answer to know there should be an asymptote there. If you go back to the original problem, 3 times x, so 3 times negative pi over 12 gives you negative pi over 4, and negative pi over 4 plus pi over 4 gives you 0. So secant at 0, you're looking for r over x, and so if you go to the right, that'd be 1, 0, so that'd be 1 over 1. So secant at 0 is 1, and then -2 minus 1 gives you -3 for that graph. That doesn't make sense. Give me a second. But I will show you guys a second alternative, which many of you guys are mixing this. So again, in class, I taught you guys just to graph cosine in green, and then erase it, and then graph above it, and then asymptotes, where the original graph would have had the x-intercepts. There's an error here. Sorry, just checked mine. And I recognize that the asymptote should be there at pi over 12 and at 5 pi over 12. So the graph, the blue should be kind of in here, and then the asymptote, and then going in this direction. And the reason why is pi over 12, let's pick here, this would give me pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4 or pi over 2. The coordinates at pi over 2 are 0, 1. So cosine is 0 over 1. So the reciprocal of that of secant is undefined. So you should have it undefined there. For those who took version A on this problem, I'm going to take a look at your graphs electronically because I've scanned all of your tests, and then I'll award points accordingly. Thanks for being patient. This side was 60, and then that side was 40, so that was out of 100.
man.